Okay, we're going to continue our demo now and continue our grid building process. So let's open our main grid.m file. And now what we're going to do is we already selected the domain and boundary corners of the grid. And so we'll proceed in actually building the grid file. Now in this case, I'm working on a grid for the British Columbia. Approximately, let's say I want to do here, say a coarse grid, 15 kilometers. Okay, it's a coastal grid in this case. And so here I define the grid file name. This is what we did in the previous demo. And so I go all the way down to here where I plotted the grid. And so I'm going to select this and I'm going to plot my grid again. So I'm going to go in MATLAB here. And so here's my grid. So this is a rotated grid, with respect to the geographical north-south, and it follows the British Columbia coast here, the Canadian coast, and then a little bit of the Gulf of Alaska. Okay, so now this is the grid. The next thing that I'm going to do is I have to decide. So far, I only have the corner of the grid, but I have to decide, how many points in the x and y direction I want to have in the grid, and in particular, what resolution. This is going to set the resolution of the grid. To help me in selecting the number of grid points in the x and y direction, I have this routine here that I'm going to do here. I'm going to type that. And what this tells me, that the total distance in the delta x direction is about 1,200 kilometers, and in the delta y direction is 22,043 kilometers. So now if I want to have an average resolution, say of 15 kilometers, I put 15 here. And this tells me that to achieve such a resolution, I need to have about 149 points in the y direction and about 80 points in the x direction. Okay, so of course you don't have 149.5 points in the y direction. You usually typically want to have like even numbers. So actually let's go back to our MATLAB script, and if you execute these two things, okay, it will round these directions, and it will define two variables. The first, cell edge 1, which is the y spacing in the y direction, and it tells you basically that you have 150 points here. It just rounded this number. And in the cell edge 2 is a parameter that has the number of grid points in the x direction, and with the 15 kilometer resolution that you selected for the x spacing, it's going to be approximately 80 points. So it just rounded up these two numbers. Now, do I like 150 and 80? I could definitely go with that. These numbers are even. However, there's something that you need to know about ROMs in particular. That is that the actual number of grid, if suppose that you're running a parallel application, typically you want the number of grid points to be dividable by 2 or a multiple of 2. Better, especially if the grid is very big, you may want to have 16 CPUs, and so you want to divide the domain in 16 portion. Now, how do you actually define the number of grid points? Well, for example, if this is 150, the number of computational points of ROMs is going to be 150 minus 2, okay, which is 148. And this is the number that has to be multiple of 2. Okay, so in this case, this is divisible by 2. In fact, 148 divided by 2, that's fine. And you can even divide by 4, so that's very good. Well, actually, you can divide again by 2, sorry. So that's very good. Now, if we go at the, so we could do the first number, then is fine. 150 is fine. How about 80? Well, if we do 80 and we divide, we subtract 2, we have 78. If we divide 78 by 2, it's divisible by 2 at least once. And I think, this is probably enough to be divisible just by 2 because this is a fairly small grid. So these numbers are kind of okay, and so I'm going to keep them. And once again, I executed this part here, so I'm just going to remind myself what those numbers are by re-executing this. Okay. Okay. So this is cell edge 150 and 80. I typically like to make a note here. Okay. Selected 150 times 180. Okay. For BC grid, for the British Columbia grid. Okay, so once I know what the number of points, then I go to the next step, and here there's a note, by the way, that tells you exactly what I just said about parallel machines, that you prefer to have that the number of points in the x and y directions are multiple of 2, 4, 8, or 16, depending on how large the grid is. If you have like over 500 points, you may want to have a number of grid points that are divided by 16 so that you can have more CPUs at the same time. Now remember that the number of grid points that needs to be divided by 2 is not actually the value cell edge 1, you know, which in this case was 150, but it's actually the value of cell edge minus 2. So in this case, if it was 150, it is 150 minus 2, which is 148, and 148 is the number that needs to be divided. That needs to be a multiple of 2 for 16. The same is true for the x direction. Okay, so we've done that, and now we're going to use another program called cgrid to actually build and generate the grid file. Now here there's some information of all the various steps that you need to perform, and the first one of course is to run this command here, which I'm going to do here in the MATLAB window. So I'm going to close all, and then I'm going to execute cgrid. So now I have this very nice map of the world, and the first thing I'm going to do is I'm going to load the boundary file that I created, which is one of the inputs that he needs. And so if I go here, I have corner grid BC, so I'm going to select that, open. Okay, so now I have my grid over there, which is kind of nice. I can zoom on in this region here. Okay, and then I can put zoom off. Okay, so now I see my grid. By default, cgrid will put a certain number of grid points in the x and y direction, but I want to change that to reflect my choice of number of grid points, and I do that by going in view and then setup. And here you have the two parameters, which are cell edge 1 and cell edge 2. Okay, and here if you remember we had these parameters configured, so this is 150 and 80. So I'm just going to go here, select this and put 150, and then select this and put 80. Okay, and then I type OK. I wait, and now you see that the resolution of the grid is more fine, and and basically I computed all the grid parameters like the delta x's, delta y, and so forth in this rotated framework. So at this point I'm actually for the way that I use cgrid, I'm actually kind of done. So I'm going to press save. It's going to ask me to save a mat file with the information. I'm going to call this cgrid.mat. Okay, and I'm going to save that. Okay, and once I save the file, I'm going to quit this program. Okay, so then I go back to my little window, and if I go here, what I've just basically done are these steps that are enumerated here, which are here to remind you. Okay, once I've done that, I now have the cgrid mat file that I created, right? ls minus RTLA. You can see that I have created the cgrid mat, which has all the information of the grid, but as a MATLAB file. Now I want to convert that into netcdf file for the grid, and I do that by executing this command like this. I type that, and I wait, and now if I type ls minus RTLA, you see that now I have my bc grid.nc file. Okay, at this point that I have this grid file, of course this grid file only has the grid computational domain, the x and y direction, but it's missing still the coastlines, or the land mask if you like. It's missing the bathymetry, and these are things that I need to provide in my later demos. Now one thing though it does have, it already has, for example, the rotation f Coriolis, because it's computed from from within cgrid, so that's good. So now the next step for me is to configure my ROM's numerical toolbox, the RNT, to actually have this grid inside its configuration. And to do that, I once again I find the location of my grid info file, which I do like that. Okay, and if I type config file, okay, I find that it's there. So now I can just open this file here. I'm going to select this file, go in this window here, and in fact actually there's a nice thing you can do in MATLAB. You can do just Unix config file, and if you did that, it just opens your VI editor. Okay, so now I'm here inside the RNT grid info file, and I'm going to put the new configuration. Now in this case I'm going to look for a configuration that is similar to the one that I'm doing. Okay, I'm going to go at the top of the file, I'm going to scroll down, and for example the North Pacific grid is kind of similar enough. Okay, so I'm just going to go down here. I'm going to copy, an existing configuration, and now I'm going to change it. Now instead of in Pacific, this grid is going to be BC, which is British Columbia. I'm going to change this to be British Columbia. Yeah, okay. Then I have to provide the full path to the grid, and in this case this path is correct. It's because it's NEO GFD class GFD root ROMS grid, but the name of the grid is not N Pacific, but it's called INS BC. Okay. And then I have to decide the number of vertical layer, which I'm going to leave to 30. The number of stretching parameters, which I'm going to change to something like 5 and 0.4. And we'll discuss the stretching parameter in a later lecture when we do the vertical coordinate system. And so this is I've just copied kind of an existing example. And I'm going to save this. Now keep in mind that these vertical parameters, theta s and theta b, even though I set them in here, I can change them later. This is not, the grid file itself doesn't care about the vertical stretching of the ROMS grid per se, because that's done within the Fortran code. So for now I'm just putting these parameters, but we can change them later if we want to. Okay, and one important thing here, there's this HC here parameter, which is the minimum depth of your grid. And in this case, I don't want it to be, I'm going to later set it to be something like 20 meters, for example. So I'm just going to put that HC to 20. So I'm going to save this now and go back to my script thing. And now that I have the grid configured, I can load my grid by just doing this command with the grd rnt grid load. And I do that. And now I have my grid here. Okay, so now I'm going to actually check this grid. And one of the things that I'm going to check first is the spacing of the grid that I selected was 15 kilometers. So I can use now the RNT PLCM. And the grid spacing is contained in the GRD array, and it's grd.pm, which is the spacing in the y direction. But as you remember, pm is actually a grid parameter that it's 1 over divided by the spacing in meters. So in order to know, if I want to know the spacing, I have to do the inverse of this quantity. And then I just say that I'm going to plot it onto the GRD, this particular grid here. Okay. So what I find here is that the average spacing has a latitudinal dependence, and on average is 1.510 to the 4, which is basically 15 kilometers. And if you're not convinced, you can go back here and divide the meters by 1000 to plot it in kilometers. And if you do that, you can see very clearly that this is 15 kilometers. And it has some latitudinal dependence associated with the fact that, as the lines of as you go towards the pole, the spacing between two longitudinal points is decreasing, and so it gets more tighter, and so you can see that the resolution is actually increasing as you go towards the pole, and that's fine. Okay, so now I've checked that, and I can, for example, now plot the topography of this grid, grd.h. And if I did that, it gives me an error because right now I don't have any topographic, I don't have a topography defined yet. So this is what we're going to do in the next step. Okay, so for now we basically stop here when we load our grid here, and we have created a grid file. Now we're going to populate it with the topography and the landmass which characterizes the coastline.